Hello, everyone. Here we go. We'll try again. 5, 4, 3, 2, 1. Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our special CoCoRaHS Weather Talk webinar on the significant weather events of 2023. Seems like a long time ago now with all the stuff we've had going on in the last 2 weeks. Well, a very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from, well, what seems like somewhat a warmer Fort Collins after a 17 below yesterday. So it's warmed up here in Fort Collins, Colorado, from the Colorado Climate Center. For those of you who are unable to join us for our live broadcast, we're recording today's talk, and it'll be available later this week on our website. All of our Weather Talk webinars are sponsored by the generous donations from listeners just like you. Well, we're excited to have back with us, as we do every January for the last couple of years, our good friend Greg Carbin. Greg is the Chief of Forecast Operations for NOAA's Weather Prediction Center in College Park, Maryland. And each year, Greg puts together a presentation on the top 10 weather events in the U.S. during the previous year. Greg has given these talks to pack rooms at various weather meetings around the country. Since today, Greg, it's great to have you back with us again this year, and thank you for taking the time to do that.
Oh, more than happy to join you today and the rest of the CoCoRaHS viewers and listeners out there, Henry, and thanks again for having me back. So without further ado, let me see if I can share the screen here with the presentations. We're going to do that, and we're going to do that, and hopefully you will see the first slide with events number 1 and 2. Are we good?
Looks good.
Looks good.
Awesome. Okay. So like you said, it seems like it was so long ago. It was only a year ago that we were dealing with some incredibly active weather across the west coast of the United States, specifically California, with an onslaught of atmospheric rivers, not uncommon out there during the winter months, but perhaps the intensity and the frequency of these events from last January were uncommon and definitely on the high side. And you can see the graphic there in the upper left sort of depicting the maximum onslaught of precipitation events that occurred along the West Coast. That's the entire season, basically starting October of 2022 through the following September. But really, most of these occurred late December of 2022 into January, even February and March of 2023. And the amounts of percent above normal precip there are the colors. You see California in blue, basically twice to 3 times as much the normal rainfall occurring with these atmospheric rivers last winter. In the middle there, you see the lakes recovering with this rainfall and snowfall into the mountains. And then on the far right, you see the 2 maps of California there. One is just the estimated liquid precipitation for the 30-day period from late February, 3rd week of February through 3rd week of March. This is really this was toward the end of the events. It already seen significant winter events in December and January, and then just the remarkable amounts of snowfall across the Sierra. The Northern Sierra had almost 300% of normal precipitation for snowfall, normal snowfall. And you see the house there buried. We saw a lot of pictures of snow depth basically going to the 2nd or 3rd floor in some cases, some buildings out there. And then even that snow, that moisture makes its way across the west into the Intermountain West and into parts of Utah and the Rockies. And the Alta ski area recorded its first snow on October 22nd of 22 and averaged basically 5 inches per day through April. So they had 900 inches of snow, the most snow recorded at the Collins study plot. There's a picture there in the warm season of that study plot right in the lower middle of the slide here. showing some folks below the tower there. And then another picture during the peak of, actually, I don't even think this is a peak. I think I found another picture where the tower was almost overwhelmed with the amount of snow that occurred there around Alta and the mountains of Utah. So just an incredible start to winter out there. The area of California, much of California was in exceptional drought category. It was completely eradicated by these events of last winter. Not seeing quite as much activity this winter, which is a little bit puzzling given that we are in an El Nino year, but it was that transition from La Nina to El Nino last season that really brought the atmospheric rivers to California. So for the rainfall in the atmospheric rivers, event number 1, for the amount of snow, that was memory number 2. Moving on to number 3, and this is very similar to the last event, just showing one particular storm system during last February. And it seems like we're in this pattern again right now in 2024. But this particular storm system we called the Coast to Coast event, basically stretching from the 3rd week of February through February 23rd, 24th. On the top, you see the snowfall for each day, rainfall in green and yellow, but this was primarily a heavy snow event with rainfall across the Ohio Valley and Mid-South. And you can see how that system basically came ashore in the west, moved across the Rockies with incredibly heavy snow. These are, 30 to 70 inches of snow in the mountains in 24 hours. Might be a little anomalous here in the very far right that this particular 24-hour period has a snowfall amount of near 100 inches in 24 hours. That may be a little suspect there, but it's in the mountains of Utah, which we saw they ended up with 900 inches for the season. So very, very incredible snowfall amounts. I want to talk a little bit about the map in the lower left here. This is what we call the National Forecast Chart. This is generated daily by the Weather Prediction Center where I work. This is a combination of forecast products that are generated across the National Weather Service Agency, but the forecasters here at WPC sort of compile those products together and basically build this map every morning at about 4 a.m. The maps are done for the next 3 days, trying to depict a summary product of where the hazardous weather conditions, the fronts, the lows, the high pressure systems will exist over the next few days. This has sort of been a labor of love for me. I've done a lot of the coding and the programming behind this map. We've modernized it somewhat. When I first got here in 2016, there was a rather crude mapping capability available for this. We've upgraded that mapping, and this is a very detailed script that many scripts actually that go into making this map every day. And there's an archive available as well. And again, it's supposed to provide a broad summary of where the most hazardous weather will be, but also where the general precipitation, showers, thunderstorms are expected in the days ahead. And you can find that map right on the very front page of the Weather Prediction Center's website as an overview. And then finally on the lower right here is just a loop of the Weather Service's watch warning advisory map for the several days in which these February storms tracked across the country. Sometimes we call this map Grandma's Quilt for all the colors that can appear on it. I think I saw the other day that there's something like 100 different possible combinations of color based on the different products that are issued. In this particular case, what you see evolving here are many winter storm warnings across the Rockies in the northern U.S. There's a blizzard warning, which is the orange, bright orange there across the northern plains. Eastern Dakotas, Minnesota is the blizzard warning. To the south, you see essentially wind warnings, a couple of flood warnings are the green, and then the system ends with some wind warnings evolving across the southern high plains of New Mexico and Texas. So the busier this map is, the busier these two maps on the lower part of the slide are, the busier we are. And if you look at them over the last couple of days, it's been a busy couple of weeks to start out January here. That was memory number 3. On to number 4, we're going to get kind of focused now, going from the big picture to a very small scale but impressive event that evolved across the Fort Lauderdale area in Florida around the middle of April. This is April 12th. when a almost stationary thunderstorm cell formed over the southeast coast of Florida here and brought prodigious amounts of precipitation to the Fort Lauderdale area. And you can see the depiction of the hourly increase in rainfall there, the big map here on the left of your screen, showing amounts going upwards of 18 inches. And it happened to be coinciding with the airport, with the very major metropolitan area of Fort Lauderdale. And no area can really withstand that amount of rainfall over such a short period of time. The observations on the lower right here, almost 26 inches of rain in 24 hours, most of that falling probably in about 18 or 19 hours. Just swamping this part of Florida. There's just nowhere for that water to go other than just sort of start to climb up, and you can see the result there at the airport. I have a sister who she was on her way flying down to Florida this day, and the flight, I believe, was diverted to Tampa, and they basically told them that's as far as we're going to go today. We can't fly into the airport at Fort Lauderdale. Just looking at the return frequency of an event of this magnitude, it's obviously quite rare. We're talking about something that has a very low probability of occurring in any year. We use annual exceedance probabilities here for 12-hour rainfall. And just looking at the 12-hour rainfall event here, we're talking about an annual exceedance probability, maybe a once in the 500 to 1,000-year event. So very unusual, very, very intense, and very focused right over the Fort Lauderdale area. So that was event number 4.
Jump in here real quick.
Sure.
So we have noticed with CoCoRaHS, and I've got family up and down the east coast of Florida, where we'll see a lot during the winter months of a tremendous amount of rainfall, 8, 12 inches right along the beaches. And you go inland maybe 3 miles or 4 miles, and we're down to not even an inch or half an inch. Any ideas on what's happening there, or have you noticed this before?
Right. I mean, Florida is very interesting to watch, and the topography plays a big role there, given the ocean-land interface. So, sea breeze interactions, possibly
mostly overnight stuff we're seeing.
Yeah. So land breeze interaction, the land breeze goes right out to the coast. It's possible that under the right wind conditions there, the right wind direction, that you get enhanced convergence and lift. And the entire peninsula is surrounded by a very warm tropical maritime air mass most of the time. So that air is sitting there ready to be tapped. In this particular case, it was fascinating to watch. It was really appeared to be a supercell, similar to what we see for severe weather, hail and tornado events. This was a rotating mesocyclone, essentially, that remained very stationary and locked in place. Probably a result of some land-sea interaction there, and a residual boundary, perhaps a large-scale frontal boundary that stalled across the area. It's not uncommon for fronts to get this far south in April. That's about the last month of the year they'll get there, but I think there might have been a residual boundary playing some role in this.
Oh, thank you.
On to memories 5, 6, 7, and 8. So I do say, I've been doing these talks now for 20 years, but in the past, I seem to have a lot more time at my disposal to put these events together. My current job is a demanding one, supervising almost 40 meteorologists here at the Weather Prediction Center. And when it comes time to do this annual summary, sometimes I'm really pressed for time. But I'm trying to give you the best of it here today. And it was just a summer that demanded 4 different memories, all kind of mashed together here. So smoke, heat, flooding, and wind. And we'll take them, I think we'll take them in about that order. Just looking at this particular slide, I think I actually put this together before the annual memories talk at some point during the summer, realizing that we had a multitude of significant hazards we were dealing with. And we'll start with the smoke. Everyone, or most everyone this summer became familiar with the air.gov website, where you can, it's similar to CoCoRaHS, actually, you can get a unit to report air quality, particulate matter, small scale particulate matter in the air, and have that report into the system. And whether it's smoke or smog or car exhaust, these systems are fairly common measuring units across the country. And you don't want to be you don't want to be in anything other than green, which is, no problem, clean air. But you get to the oranges, the reds, and especially the purples, it's very noticeable. And it has a huge impact on health. Folks that typically wouldn't have a problem breathing, and when it gets into these situations where there's a lot of particulate matter in the air, folks with asthma are very, very debilitated by this poor air quality. Very difficult to get out of it too. I mean, you're going to sort of remain inside with the windows closed and maybe air conditioning, but outside there really isn't any safe place to be when the air quality is this bad. So that we'll talk in a minute about where this smoke all came from, but it was widespread. It was brought into the United States essentially from Canada, but many days had very poor air quality across much of the Midwest, upper Midwest, and East. Now, this is not uncommon during the fire weather season in the Western United States. Those of you in the Rockies and in especially California and the Northwest know that you can go several weeks sometimes with rather poor air quality associated with wildfires, but it's a little less common in the East. And, I didn't give it too much thought. I mean, I looked at the map every day, but I was usually up in the Northeast, and I was visiting, I think, up in Vermont during one of these events, and I saw where the following day we might get into some yellow or red poor air quality. I went out for a hike that day, and I thought, well, isn't this interesting? The sun, you can definitely tell, is a different color. It's not a bright sunny day. It's more orange hue because you've got a lot of smoke in the air. And at one point I did smell a wood smoke, which was probably originating in Quebec, north of me. And I went on a walk, and that evening I had a horrendous headache. And only later did I realize that's probably due to the poor air quality. Didn't give it much thought at the time, but realized later that it has a huge impact. The flooding we'll talk about in a little bit too. The heat was relentless across Texas, Louisiana, Mississippi, Alabama, Florida, up into the plains. But really Texas and the Gulf Coast bore the brunt of days after days of incredibly high heat index values. And the heat index is what's showing up on those dots in the middle of the screen here on one particular day during the summer. You see heat index values there over 110 degrees, very dangerous. There's a connection between that heat and the wind. The derecho there that occurred in June, there's a relationship between that heat that builds under the upper ridge, which essentially suppresses thunderstorm development. But usually you'll see thunderstorm development on the edge of that ridge of high pressures, which is what we saw across the upper Midwest there. And that's just a zoom on the derecho that occurred from Iowa across parts of Illinois and Indiana. And then the lower right is a picture of the power outages associated with that derecho. And I think we've got a loop coming up with that. But let's talk about the wildfires in Canada first. So this is where the bulk of the smoke came from that gave the folks across the lower 48 states a real problem during the summer months. This loop runs right through the summer from May through September. And you can see the fire starts up in Canada and then the area covered. And they had broken all records in terms of the amount of area burned across Canada. Widespread and nearly continuous wildfire activity across parts of Western Canada, but even an outbreak or two across Quebec there you see, and some of that smoke was making its way into the Northeast. It made for beautiful sunsets, but obviously very poor air quality and very concerning with regard to its anomalous numbers here as far as the area burned. We started out very dry, and all it took were a few lightning strikes to get some of these going, and then they burned all summer. The heat is a loop on the upper left here of the National Weather Service heat headline products, just focusing on heat advisories or heat warnings, June through August. And you can see those areas that were most impacted across the South Central United States, a little bit in the Southwest as well. I did a loop on the right here of the number of days for each month that were at or above 100, just as an air temperature, not heat index values. And again, really shows up here how much of the month of July, the Southwest saw daily. That's not really a surprise. It's sort of climatology out there. But what is perhaps a little more anomalous are the number of days of high heat across much of Texas. And we know that the urban corridor, urban areas tend to hold the heat longer. It's easier to heat up during the summer months. And it was ugly across Texas. And then finally, the statewide average ranks for June, July, and August really show basically from New Mexico across the Gulf Coast to Florida, one, if not the hottest summer period on record in those states. And really made worse by the fact that you had very high sea surface temperatures in the Gulf of Mexico and the Atlantic, contributing to incredibly high humidity and very high dangerous heat index values. Here's the derecho. Let me start the loop here. So this was late June, started with a cluster of storms. And again, you can almost see on the report map here in the lower right how there's arc of incredibly strong damaging winds occurs right on the edge of the capping upper high pressure system that's dominating the southern U.S. with all the heat. But all of that energy gets pent up under the ridge and is released with a strong or even a modest disturbance. Once you release that energy on the edge of the cap, you can really see these storms take on a life of their own. And that's exactly what happened with this particular event, spreading into Illinois as a nice bow echo across the Illinois-Indiana border, and then making a bit of a curve toward the Ohio River, the lower Ohio River Valley there, with widespread damaging winds associated with this event. And there were a number of these events this season, not really surprising given the amount of available energy from the heat and humidity across the southern plains. Move on to memory. Let's see. I think I got it here. Pause that for a moment. So Vermont got slammed in early July with incredible flooding associated with a very unusual non-tropical weather disturbance. The area had started the summer months actually on the dry side. There was ongoing drought across parts of the area. And I was up there for parts of May and June and started to realize, the pattern's changing a bit. They were getting daily thunderstorm development over the mountains. A lot of these storms weren't moving very far. I had to come back to work just before the July 10th event, but I was up there the weekend before the heaviest rainfall. And believe it or not, this picture of the washout was taken before the onset of the rainfall that really brought widespread flooding to the state. So this event actually occurred about 2 days beforehand and gives you some idea of how primed they were for dangerous flash flooding because the ground was already so saturated. And so what they had another disturbance come up, and this one really did look like it meant business, with anywhere from 5 to 10 inches of rainfall locally on top of saturated areas, on top of areas that had already seen flash flooding and mudslides, and the result was devastating. And very similar in some places to what they saw with Hurricane Irene back in 2011. So there's a video here I'm going to play. Too much water in Woodstock, Vermont, which is where my in-laws live. And this is the flood of July 2023. And the reason I picked this video, I might have to go forward a little bit here, but there's a very interesting part of this video where you'll see something come down the river. I've never seen a video that has shown this. We've heard of these problems before, but I've never seen a video that actually has shown this. So I'm going to jump ahead a little bit to show you that. Let's see here. And at first it looks, let me see if I can go full screen too. So there's a before and after picture along the Ottaquechee River in central Vermont. I'm going to go here. Here we are. So this is interesting. You'll watch on the right of this video. You'll see, if they pan right, you'll see what looks like a train coming down. There's some smoke coming out of the woods here, and it takes a moment to go around through the woods. And anybody guess what this might be that's coming out? Maybe you've seen the video, but I was quite shocked when I saw this. It appears to be a very large, it'll show up here in just a second, a very large propane tank, and it looks like it's leaking. Yep. So one of the dangers of flash flooding, you get a tank like that that gets floated away and then hits a rock and causes, luckily no explosion in this case, but just one of the episodes of the flooding that occurred up there in Vermont. A lot of roads washed out, a lot of damage, again, in areas, some that had been repaired from Hurricane Irene. And I did go back up about a month later, and it was very evident that this was a devastating flooding event for July 2023.
Greg, can you show us on the map where WxTalk is?
Sure. It's right about the middle of, just south of the middle of the state, right in here. It's sort of halfway between Lebanon, Hanover area, and Rutland, Killington area.
Thanks.
Yep. A very sad event here in early August. The Lahaina fire that basically devastated the city here on the islands. The only reason I brought this one in is just to discuss the anomaly that resulted in the high winds that drove the wildfire. There was a lot of discussion. There still is, if you search for videos on this event, that it was the hurricane passing. I think it was Dora. Was passing to the south of the Hawaiian Islands, which are sort of here. The fire is in the red circle on this map, but that really did not play a significant role. It was this anomalous high pressure system that had set up and become established across the north central Pacific. And the winds, the northeast trade winds around that high pressure system that produced the strong winds and the downslope dry winds across the island here that drove this devastating wildfire in Hawaii, the deadliest on record for Hawaii. And there are other issues as well. A lot of discussion about how agriculture has changed out there, how water has been diverted from certain places too. So a combination of meteorology and human changes brought this devastating fire about. I think we're going to start to wrap it up here. I think we're on, that was number 9. I don't know why I don't have this numbered. This is number 10. Very unusual Hurricane Hilary that moved from the Eastern Pacific up the Baja Peninsula and into Southern California as a tropical storm during the 3rd week of August, bringing, again, somewhat beneficial, but also devastating rainfall to parts of Southern California. And you see here a water vapor imagery loop with the hurricane forming and moving rapidly north and kind of being absorbed very quickly. All that moisture wrung out across the lower Colorado River Valley and parts of Southern California. Very anomalous to see the rainfall that occurred across Southern California with this event. Anomalous to see a hurricane track of this nature into Southern California. Looking at the rainfall amounts, about 600% of normal. So hugely unusual in August to see really any rain across this part of the country. And you can see here how anomalous that rainfall was associated with Hurricane Hilary. That was memory number 10. My last slide here sort of summarizes the summer. One afternoon, I just sort of came up with this, and as we were burning, choking, sweating, and soaking across much of the United States in summer of 2023. Have to say that, pick your poison here, because there weren't many areas of the country that were spared some form of devastating weather events during during 2023. So another memorable year, and I think I've wrapped it up here in about half an hour, and that should leave us some time for questions. And thanks again to CoCoRaHS for having me.
Greg, thank you again for doing this year after year, and we really appreciate it. And I know it takes time to compile all this, so thanks for taking time out of your day. Hey, quick question: were there any tornadoes that kind of didn't see that in the events this year? Was it a kind of a low year for that?
I was about average. I believe the numbers were pretty average. There were definitely some standout events. As you know, my job from the Weather Prediction Center is a little different from what it was when I started
Right. Yeah.
at the Storm Prediction Center. And I probably should spend a little more time looking at those events, but I got my hands full with heat and extreme rainfall.
No, that's fine, folks. If you want to, if you have any questions for Greg, he'll be glad to take them here in the next couple of minutes, and we'll kind of shorten this up because I know you have a very busy schedule today. So as they come in, we'll take a look here. And oh yeah, so Dennis out of Montana has asked with the South Florida event, both and the Vermont event, were any CoCoRaHS reports able to be used in any of those to help you guys with that?
Oh, yeah. CoCoRaHS is probably one of the first sites that I go to in the morning when looking at these extreme rainfall events. And so they're critically important. They get into the database. They're utilized by the local National Weather Service offices, and we'll occasionally refer to their products too for those observations. I see
Great.
Dennis also has a question about the difference on the max rain, and I can answer that.
Yeah,
so the loop there indicated a max rain of 18 inches. I think it was over, I don't know if it was over 24 hours or something like that. Those are estimated values based on radar. And then the 25-inch on the graphic that was on the right side are actually observed amounts. So there's going to be differences sometimes what's estimated and what's observed.
Okay, thank you for answering that one. Anita wants to know if you could quickly go over the difference between the relationship between heat index and wet bulb temperatures. What's involved there?
There is a difference. The wet bulb temperature is an actual value that is computed, and it is it's similar to the amount of moisture that the air can hold at the temperature that it's at. The heat index value is actually a rather complex calculation that there's some debate about that calculation. It tries to take into account what a quote normal human would experience given the conditions of temperature and humidity. So it brings in a human factors measure to try to understand what the heat, how the human body responds to the heat, where the wet bulb temp is simply a value, a physical value.
Great. Megan writes, she was wondering if you could talk a little bit about the winter storm on the West Coast during the last couple of days, if you have any comments on that.
Yeah, so a series of storms coming into the Pacific Northwest in combination with really cold air coming out of Western Canada. A lot of that cold air is filtered westward through the Columbia River Gorge. It's a pretty classic setup for winter weather right down to sea level. And it seems like the Portland area is probably getting the worst of it, but even south of Portland, some of the precipitation falling in the form of freezing rain, which we all know can be quite devastating. So this setup with the cold air coming in from the north and moisture coming off the Pacific has really given them quite a run for their money out there with managing the snow and cold and the ice.
Well, thanks, Greg. Appreciate you taking the time today. And Greg's going to be retiring here in the next couple of months. So hopefully we'll see if we can get him back next year. Again, thank you for all the ones you've done for us. And we really appreciate your time, expertise. These have been a wonderful thing to go back and look at. So much appreciated.
Well, you know what they say about old forecasters, they either go bald, or for men at least, they either go bald or grow long beards, I guess. So now I'm looking forward to another chapter and appreciate that. I probably will never leave weather behind, and I'm looking forward to being a more reliable CoCoRaHS observer too. So there you go.
We really appreciate that. Well, thanks again. And we're going to, as we close out today's program, we want to let you know that our next talk will be coming up in March. We haven't set the date yet, but that's all about, so you want to be a meteorologist. So if you have some friends out there that are in school. I know I didn't, my guidance counselor didn't give me much advice when I was back in high school, but some things to think about. And this will be some of our friends out of Northern Illinois University putting this together. So don't miss this one. We'll have the registration available up soon on our website, and we'll have a date set for that. And before I forget, when signing off today, please take the survey that's going to pop up on your screen. So until we meet again, we wish you a good week ahead, and we want to say goodbye for now from the CoCoRaHS team. Take care.
And I'll quickly add, this is Noah with CoCoRaHS. I may have not put the feedback form on, so it might not pop up when we end this, but
Okay.
we'll see what happens. So sorry about that.
We did record though, right?
Yes, we did record, which I need to hit stop.
There we
Thanks,
go.
everyone. Thanks, Greg.
Thank
All
you,
right.
guys. We'll talk to you later.
All right. See you later.